Hello everybody. If you were here yesterday, you got the basic vocabulary that I've put right up here just kind of as a reminder. All right, and so this box right here is on your worksheet today. So take a look at this right here as reminders and go ahead and start filling in what your thoughts are right here. Okay. All right, so remember, a coefficient is a number that's multiplied to a variable. So in this case, we have the variable of an x, and there's a coefficient of a 5. We have another variable of an x, and it has a coefficient of a 7. Okay, remember, a constant is a number that remains the same, so to speak. Okay, I would call it a plain number, and it does not have a variable multiplied to it, and we make sure that we get the sign in front of that number. Okay, then for our exponent, there's an exponent that we see. It's right here, right? So that's usually the one that we get automatically. But for those of you that are clever thinkers, this variable right here does have an exponent. It's not written there, but technically every variable has an exponent of 1 if it's not something else. So technically, you could put a 1 right there also, and that would be correct. All right, let's keep moving on. So today we are going to be combining like terms. So the first thing we have to talk about, remind ourselves about, is what it means to be a like or a like term. And you are a like by your letter, is usually what I say. So terms are alike by having the same. Now we're going to be professional math students, so we are going to, instead of saying letter, we're going to say variable. So we have to have the same variable. Okay, so if I see an x here and an x here, we could say we're alike, but you also have to have the same exponent. Okay, so that's the full and complete sentence. You are alike by having the same letter and exponent, the same variable raised to the same power. Okay, so in this case, the x and the x squared are not alike. Okay. Now we are going to be combining like terms, right? So those basic steps are, first of all, we have to figure out what terms are like or alike. And so I put a silly little graphic here. This is a pomegranate, that's a lemon, that's an avocado, and now we have things that are repeating our pictures, okay? So this is little graphics, but we could think of that also as 14 times the variable p. All right, so now once we find something that's alike, okay, so I'm going to say this 14p is like this pomegranate right here. We have a negative 6p. Those are alike. Okay, some of your teachers may have taught you to say circle like terms. Okay, now once we identify what's alike, we combine, which in this case means we're going to either add or subtract, and we're only going to add or subtract the coefficients, not the variables. The variables are going to stay what they are. So if you have pomegranates, then you are going 14 subtract 6 pomegranates. So 14 minus 6 is 8. Now our answer is not just 8, because we are talking about pomegranates, okay? And we would do that for each term, okay? But we're going to kind of bypass that. I just wanted to give you a visual. Now let's move on to something that's actually on your paper. Now keep in mind, first thing that we have to do is we are going to identify like terms. And the very third step up here that I didn't really mention is that eventually we're going to put things in alphabetical order. All right, so what we'll be doing as we're looking at our terms, we have this thing right here. We have a 6 and an A. You could think of that as 6 apples. I'm going to look across and I'm going to find what's like him. And I see an A, and in front of that A is a subtract sign, and it looks weird without a number. There will always be the number 1 in front of a variable if there's not a number already there. Okay, so we've already taken care of the A's. Now we've got different letter. I see some B for blueberries. Okay, so I see a -2B, and I see a +3B. So now we've identified the like terms, we've collected them, and now we're going to combine 6 minus 1, and that mathematic expression becomes 5A. Now we have -2B, and we're adding 3 B's. All right, we are taking the coefficients, the -2 plus 3, that becomes a 1, and B for blueberries. Now that is a +1, and so officially our final answer would be something that looks like this, because we don't need that 1. All right, this answer is the same as this answer. We like this the best, but if you left it like this, it would be okay. All right, so you can go ahead and get ahead of me a little bit if you want to. For those of you that need a little bit of help, I'm looking alphabetical, so I see 7 apples, so I'm going to put that right over here. I see another apple, and I'm going to make sure that I get the 2 and the positive sign in front of it. And I don't see any more apples. Okay, and I'm going to go ahead and combine those. 7 plus 2 is 9A. Now I'm going for the blueberries here. We've got a negative, an imaginary 1, and a blueberry. And I see a plus B, so I'm going to take the plus. There's that imaginary 1, and I've got a blueberry. Okay, that's all of the blueberries that I see. Now, -1 plus 1 is 0B. Well, 0 doesn't have really a sign, but let's just put a plus sign in there just so it has something to connect. And now I see some carrots here. So I see a -5 carrots, and I see a +6C. They are alike, so then -5 plus 6 becomes +1, and that's carrots. All right, so now my final answer would be 9A, because there is nothing here, there's 0 blueberries, we're not going to write it in the final answer, and we have carrots, and there's 1 of them, and we have permission to not write the 1 and just put that there is a carrot there. All right. It's very common that we may see some problems that have multiple choice. When we have multiple choice, it's still best to start working that problem like we know how to work it, okay? Let's just start with, how about we just go with 5? Looks interesting here. All right, so I see this -3A, and I see this -5A. They are alike by their letter. When I combine them, I know that that's -8A. Now what helps me with multiple choice is now I can, if I'm confident with what I put there in blue, I can cross out some answer choices. All right, so let's go find some blueberries here. And I see a +5B. Oh, yep, and I see another one right here. I see a positive and then that imaginary 1B. And that's all the blueberries that I see. And that is a +6B. And out of the 2 answer choices of -8A, I see a +6B right there, but that doesn't match, so I feel confident. Now, if I want to be extra careful, I'll go find some carrots here and just double check that -4 carrots plus the 6 carrots, that would combine to 2 carrots, and that matches that final answer, so I'd be confident with A, okay? I'm not going to work number 4 with you. That's something that you can go back and practice on your own. I want to make sure we get into this Next section, we're still combining like terms, but now we're going to have something that looks like this. And the instructions might say simplify, it may say distribute. Okay, so I want to remind you of PEMDAS. Please excuse my dear Aunt Sally. Usually what we say, okay? Now the very first highest priority is parentheses, okay? Now that means we look inside the parentheses, and if we can do something in those parentheses, combine them, we do. But since x is not like 3, there's nothing to do in the parentheses. There's not any exponents, so now I'd either be looking for some kind of multiplication or division. Now, when you have a number right next to a parenthesis, so we've got the 2 and we have the parentheses, then that means multiplication. There's that little implied multiplication dot, okay? So just like a teacher distributes papers, everyone gets a paper. So we are taking this 2 and we are multiplying it to that x. Now, when you see a variable that does not have a number in front of it, let's go ahead and put that 1 in there, okay? We're distributing papers. Everyone's got to get the 2, all right? So that 2 is going to multiply by that positive 3, that 3, okay? So to total this up, so to speak, 2 times 1 is 2, and there was an x in that group, so that belongs in the answer. And then this 2 times 3 is 6, and that's a positive 6. That's our final answer, okay? We can't do anything else because the x is a different type of term than the 6. So that's our final answer. Okay, let's move on to 7. Again, if we look inside the parentheses, the x and the y and the 4 are all different terms. Therefore, we cannot combine them. So there's nothing inside the parentheses that we can do. There's not any exponents, so we're going to be back to looking for multiplication, which is right here between the 4 and the parentheses. That means we're taking the 4 and we are multiplying it to the 1x. Some of you are going to want to go ahead and do that math, and that's okay. We can do that right now. So 4 times 1 is 4, and there was an x in that. So that has to go down to that part of our answer. All right, we have a bigger class this time. All right, we have the 4, and we're going to multiply times the 2y. So our coefficients get multiplied. So 4 times 2 is 8. And there was a y in that. Now that's a positive, so I'm going to go ahead and put a plus there to connect it. All right, then 4, told you it's a bigger class, that 4 has to multiply to now a negative 4. That's very important. Okay, a lot of times if I see a negative, I'll go ahead and circle it to make sure I get that negative with it. Okay, so 4 times negative 4 is negative 16. So my final answer would be 4x, which is different than the positive 8y, which is different than the constant of 16. Therefore, that'd be our final answer. All right, now we're getting a little bit more involved, but we're going to have the same concepts. Okay, we're looking, thinking of order of operations. We do have a parentheses, but inside this parentheses, we have a y and a minus 3. They're not alike. So there's nothing to do in the parentheses. We have no exponents. So we must pay attention to this multiplication right here. That negative 5 is asking to multiply to the 2y. At the same time, the negative 5 sees that negative 3 also in the parentheses, so negative 5 times negative 3. This parentheses right here ends, okay? And so it's kind of like this big fence that no more distributing happens, okay? So let's go ahead and total up what we have so far. So this negative 5 times this 2 is a negative 10y. And this -5 right here, this -5 times -3 multiplied together would be a +15. Okay, now we cannot hurt anybody's feelings. And notice there's this +1 right here. So if we want to make sure we include everyone, well, technically that +1 gets dropped down to what we're thinking our answer is here. But then we should notice that this +15 is like a +1, so we will combine those. The -16y stays, but 15 plus 1 is 16. That would be the most simplified version that we can get. All right, now let's kind of look at what number 8 looked like and look at what number 9 looks like. We still have kind of the same routine. There is nothing in the parentheses that can combine, and there is nothing in this parentheses that can combine. Okay, so nothing to do with these parentheses. There's not any exponents. There's a couple of places where multiplication exists. But we will start at the very left-hand side of this and just start making our way through the problem. So we have 8 times, the n has this imaginary coefficient of 1, so I'm going to write 1n. Okay, in your style, you may like to go ahead and multiply that and write 8 times 1 is 8n. At the same time, the 8 sees a -2 in the parentheses, so 8 times -2. Total that up, that becomes -16. Okay. Remember that parentheses kind of stops the distributing from happening. We move on to this next little section. Here is a parentheses and a 2 that's multiplied right by it. And what's super important is that we make sure that this 2 stays with that negative. Okay, so now in the distributive part of this, -2 multiplies to the 1n. I'm going to go ahead and multiply that. That's -2n. Then I see a -2 that wants to multiply to a +2. That totals to -4. Okay. So now we have these 4 different terms, but that is still not as simplified as it can be because we have things that are alike. Okay. I have 8 Nutter Butters. Love those. I have some Nutter Butters here. And remember, if we find a variable, we take its coefficient and its sign. So 8 Nutter Butters subtract 2 Nutter Butters makes 6n. Okay. Then I see -16 right here. That's a constant. And -4, that's another constant. They are alike. So if you owe $16 and then you borrow $4 more, you're going to end up owing $20. Now that the 6n Nutter Butters is different than this money right here, then we are done. That is as simplified as we can get. Okay. All right. For the video purpose, I'm going to leave this for you to try on your own. Okay, but then I want to give you a hint right here for number 11. We talked a lot in the earlier questions about this PEMDAS, where we're supposed to look inside the parentheses and see if there's any math to do. Okay, now this one, snuck that in there, this x and that x are alike. So inside that parentheses, we have a 1x, and we're subtracting a 7x. So 1 minus 7 is -6x. So inside the parentheses, we found something that we could simplify. So now we don't have this parentheses anymore. We know it's -6x. Okay. Now let's go take a peek in this next parentheses. All right, so we're going to be adding whatever we come up with in that next parentheses, but I'm seeing an X and an X. So if I want to come off to the side, I've got a 3X right here in this parentheses, and I'm seeing a minus 2X. So I know that totals to a 1X. Okay, so I'm just going to write it down here just because. And then inside this parentheses, I have a positive 5. Doesn't have an X with it, so I have to kind of keep it by itself. Then, as you start putting each little part together, I'm hoping that you recognize that these X's are alike. These two terms are alike. So if I have negative 6 and I'm adding 1, that would be negative 5X. We still have this plus 5 that we must bring down to our final answer. Okay? All right. That was a lot. Hopefully it's review for us. You have 6 problems on the back of your worksheet that I would like for you to give a try on your own, see what you can remember. We're trying to figure out how we can best support you, so it's very important that you try hard, ask questions, that kind of thing. And all of these have examples worked out for you on the front side of the worksheet.